So speed, velocity, and acceleration. Speed, velocity, and acceleration. Well, we're just going to be talking about speed right now. So the rate of distance and time. It's a rate, okay? Rate being one unit compared over another unit, okay? In this case, it's distance over time, which is, in fact, the first question. Define speed in terms of distance and time as a rate. It is actually a rate of distance over time. Okay, that is what speed is. And of course, looking at this mathematically, we can actually see that if we multiply both sides by time, we multiply time right here, we multiply time over here, time will cancel, and we're left with speed times time is equal to distance. Okay? We leave it in this form right here, and we say, well, let's get time by itself. So we'll divide both sides by speed, and we'll get distance divided by speed is equal to time. Okay? Again, multiply both sides by time over here. You get speed times time is equal to distance. And divide both sides by speed, and you get distance divided by speed is equal to time. Okay? That's the mathematical relation to speed, distance, and time. So calculate an example of average speed. So if we look at, in your book on page 20, figure 2.2, I loosely drew the image of it without the town names, but basically some car starts here, starts down here at the bottom, start, and ends over here, making a turn here. And the first leg, it's a little bit more squiggly than what I drew, but it was 140 miles over a period of time of 2.6 hours. That was the period of time for the 140-mile leg. The next, after he turns left, is 120 miles for a period of 2.4 hours. So I'm guessing from the turn over to the end is 120 miles for 2.4 hours. So basically what we do is we add the two legs of the distances together. We get 120 plus 140 is 260 miles. Add the two time periods together to get total time that you were driving, and that is 5.0. That is 5.0 because it is 2.6 plus 2.4. So you get 5 hours, so it's the total time. And to get an average speed, what you do is you take the total distance divided by the total time, and it'll give you an average speed. So 260 divided by 5 is what we would have. 260 divided by 5 is equal to, do that real quick. We can say 260 divided by 5 would be 4, or it would be 5, 25, 1, 0, 2, equal to 52 miles per hour. Okay, 52 miles per hour. It's a reasonable speed, right? So, that is exactly how you calculate average speed, all right? Give two examples of rate. So what is another way we can say a rate? Here we're saying it, for speed, we're saying it in miles per hour, meters per second. What is another example of a rate that is not speed? How about when you go purchase gas, right? How do you say that? How do you say it's, how many dollars is it per gallon, right? What's the cost of gas right now? It's $1.87 a gallon right now. Or what is your fuel consumption rate? Well, I can drive 20 miles per gallon, right? There's another one. So those are three right there. Okay, when a speed as calculated in terms of how fast an object moves over a period of 1 hour, would that number increase or decrease if it were converted from a period of 1 hour to a period of 1 second? example is converting from meters per hour to meters per second. Would the overall value increase or decrease? So we have it up here on the board. 60 meters per hour, and we want to go to meters per second. Okay. Remember what we did? We learned using the train track method. We put our 60 meters per 1 hour. Put the 1 hour in the bottom here, and that is equal to 1 hour, or I'm sorry, converting hours to seconds. We say 1 hour divided by the number of seconds there are in an hour. 3,600 seconds are in an hour. So we're going to actually cancel hours here and be left with meters per second. We're going to be dividing 60 by 3,600. Do you think that number is going to increase or decrease? To me, it looks like, well, that number is going to decrease. So let's look at it mathematically and put it into our calculator. We say it is, way small. 1 over 60. 1 meter per 60 seconds. 1 meter per 1 meter a minute. Okay? 1 meter per minute. All right. So 1 meter per 60 seconds. So that is that. That happens every time we convert from going from a period of hours to a period of seconds or minutes. The overall number is going to get smaller. Okay. The overall number should get smaller. Of course, if you're going the other way, from seconds to minutes, or from seconds to hours, or from minutes to hours, it should get larger. Because you're able to maintain that same speed over a longer period of time. So you should be able to travel a farther distance. Okay? Okay. So when you're driving and you're looking at your speedometer, is that device measuring average speed or instantaneous speed? Well, it's not converting the average distance, the total distance you drove. It's actually just calculating how fast your car is going at that very instant moment. So that is very instantaneous. That's instantaneous speed. Okay, well that calculates, or that takes care of all our questions. Thank you very much, and look forward to the next part.